math, numbers,
sine wave,
coordinates.
radius,
Let's factor. Let's factor more.
What we're supposed to do here is write the equation of this heart. Cool. Well, the thing is, there's a bunch of different pieces, right? So we can kind of split this up if we want to. Let's color code it and do one piece at a time. So first piece maybe we want to do are these lines. You can tell some of these are going to be lines. Maybe these pieces are not lines because they look curvy. So let's start with the part that we know pretty easily, which is that orange line. First thing we're going to want to do is find points, so it might help to label your axes. I can find any points on that line. They're all going to give me the same equation, but let's look for some easy ones. So this one at the very end looks kind of easy to me. That would be the point -4, 2. Then I've picked the point -1, -2. So what we're going to do with those is put it into the calculator to do some linear regression. So obviously we first want to turn it on. So how to do linear regression on the Inspire. From the home page, we're going to go to a new spreadsheet. We're going to start by putting an X up there in the A box, a Y in the B box, and then we can enter our values in here. So for linear regression, I'm hitting Menu, Statistics, Stat Calculations, and I'm going to pick Linear. Now when we get to the quadratic, we're obviously going to pick quadratic. So if you have a curve, this won't work. This is for linear only. For X list, I'm going to type X, go down for Y list a Y, and then I'm going to click OK. And what I have is an M and a B with which I can write the equation. Now that I have the equation written in, we can find the domain and the range because this line obviously doesn't go forever, it stops. So if I'm looking from the furthest left X value to the furthest right value, I'm going to see that goes from -4 to 1, just that piece of the line right there, that orange piece. Then we're going to look for the range, so bottom to top. The lowest point is somewhere between -4 and -5, so I would say that's maybe -4.5. And then the highest value is going to be at 2 at that point. So our range will be -4.5, less than or equal to y, less than or equal to 2. I'll let you guys pause it while you figure out the yellow equation. Now the green equation isn't just a line, it's a special kind of line, a vertical line. So what that means is the slope is undefined. And so we can't write it in mx plus b because there's no m if there's no slope, right? It's not defined. And there's also no b because it doesn't cross the y-axis. So we're going to have to use the only thing we do have on this line, which is an x value. And this line, the x value is 6. So the equation of that line is x equals 6. Interestingly enough, when we're looking at the domain, there's only one x value. So the same equation is also your domain, just x equal to 6. Now the range is going from this y value to this y value, it looks like from 2 to 4. So we would say 2 less than or equal to y, less than or equal to 4. Last but not least, we're going to look at these humps on the top of the heart. These are obviously curves, not lines. We're going to say for today that these are quadratic equations. So the key here is that you need not just 2 points like the line, but you're actually going to need 3. With those points, you're doing the exact same thing you did with the linear equation. We're going to use regression to get the formula. However, this time when we go to Menu Statistics, we are going to pick number 6, which says Quadratic Regression, because we know it's a curve. And same exact thing, X and Y. Go click on OK. This time it gives you 3 values, A, B, and C. The reason we want those is that your quadratic equation is going to be in the form y equals ax squared plus bx plus c. So you're going to go ahead and put those numbers into your equation. Domain and range here is no different. You're still looking left and right for the domain and for the range bottom to top.
Decimals.
quadratic function,
Linear.